Hello guys, we are going to answer this question. Two identical batteries, each with an electromotive force E and an internal resistance R. We can connect these two batteries in series and parallel. We put the set of two batteries in a circuit with a resistance R. We want the heat dissipation in the resistance R to be maximum. What is the relation between internal and external resistance? To answer this, let's start with series circuit. And we move around this circuit in counterclockwise, like this. And we assign current in the same direction. We start from point A, like this, and move around the circuit. The potential at the point that current goes into the resistance is positive, and the potential after the resistance is negative. For the batteries, the large terminal is positive and the smaller one is negative. So when we move from negative terminal to positive terminal, voltage increases. But for the resistors, when we move from positive to negative, voltage decreases. So we can write the voltage equation for this circuit as minus IR for this one, and from positive to negative we have minus IR again for internal resistance, plus E for the first electromotive force because we are going from negative terminal to positive terminal, and again we are going from positive to negative for this resistor, the same as what we had here, that's why it is minus IR, and the second electromotive force is positive, and then we reach point A, that's why the total voltage around this circuit starting from point A and coming back to the same point has to be 0. Now if we move E to the right side and cancel out negative sign from both sides and divide two sides by R plus 2R, after simplification we get the current in series circuit as 2E over R plus 2R. Now let's focus on the circuit when the batteries are parallel. Again, we choose the counterclockwise. And the current also in the same counterclockwise. When current reaches this point, it splits into two currents. But these two currents are equal because the two batteries are the same and the two batteries have the same internal resistance. That's why for this branch and that branch, we have half of total I, like this. The voltage increase and voltage decrease can be shown as this, and the same as what we did in series circuit, we can start from point A by writing voltages around the circuit. Minus IR for the external resistance. When we reach here, we have two options. We can go from the upper branch or from the lower branch. So it doesn't matter which one is taken. Both of them are the same. So that's why for example, we walk through the lower branch. Then we have minus I over 2 times internal resistance plus E. There is no any voltage drop after this battery. That's why when we reach A, the total voltages becomes 0. Let's move on and find the current in this parallel circuit. If we factor out the current in this equation after canceling the negative sign from both sides and dividing both sides by R plus R over 2, current becomes E over R plus R over 2. This is the current in parallel circuit, And this one is the current in series circuit. Now we want to find resistance R in a way that the heat dissipation becomes maximum. To maximize heat dissipation in R, derivative of thermal energy with respect to R should be maximized. That's why we need to find heat dissipation first and then find the derivative of that energy with respect to external resistance. That means du to dr has to be 0. Let's move to the second page and do the calculation then. I can be current in series circuit or in parallel circuit. Let's start with the series circuit. We found Is as 2E over R plus 2R. Us, heat dissipation, in series circuit becomes this. We need to find derivative of Us with respect to R and set it to 0 and then find R. Let's do it then. Derivative of Us with respect to R becomes this expression. To have this ratio equal to 0, its numerator has to be 0. After simplification, we get this and this equation, but this factor is positive and cannot set this expression as 0. Therefore, 2r minus r has to be 0. And then if we solve this for r, we get r as 2r. Therefore, rs is 2r when the batteries are in series. Now let's focus on the parallel circuit. IP we found as E over R plus R over 2. If we substitute in this equation, we get for UP as E squared times R over R plus R over 2 to the power of 2. Derivative of UP with respect to R has to be 0. Therefore, the same as what we did here, we get for this derivative, this equation, and again, numerator of this has to be equal to 0. Therefore, after simplifying the numerator, we get this equation. Again, the left side is positive, and R over 2 minus R is the only term which can make this equation as 0. So therefore, we get for R in parallel as R over 2. And this is the external resistance when the batteries are parallel. By having these values for two circuits, we can get maximum heat dissipation. So let's go back to the first page then. So we get Rs 2R and Rp R over 2. Therefore, if we compare these two with the options, we can find that A is the correct answer. Thanks for watching.